Hey guys, what's up? It's almost winter time. Motorcycle riding season is over for the next few depressing months, at least in Poland. So to speed up time and make something productive, I started working on a hopefully interesting project. This project is dedicated for motorcycle track junkies that wish to improve their racing skills and touches such subjects as lap timers, telemetry, sensors, IoT analytics, and intelligent dashboard design. So what's it all about? It's about how technology can help us making steady, safe progress into a better performance motorcycle riding. I'm talking here about improving your racetrack technique as well as understanding how your inputs translate into motorcycle behavior. I'm not sure how you are going through that improvement process or are going through that process or intend to go. But for me, mostly it was about GoPro camera recording to make sure I got good body position, as well as using lap timing software just to get reference on my improvements. Last but not least was the feel on the bike. As always, this is the most important part no matter how far you go with using technology. However, what I did not like about the above process was that I did not have enough feedback from the data to progress faster. So basically my progress into becoming a better but also a faster racetrack rider was too slow. For example, when I was doing something wrong on the motorcycle, I got the direct feedback from it, but I did not know sometimes, not always, what was the cause. Example, was it the tire temperature, wrong brake or throttle timing? So in the end, I was making progress but at a slower pace. I was simply too cautious or overcautious without knowing where are the limits. And that was quite frustrating, and I'm sure some of you were at that point, knew afterwards that you could progress much faster, but you didn't do that because you were too scared, especially when you're not so young as 20 years old. Okay, you've got a family, you've got a lot to risk, you don't want to crash, you don't want to destroy your bike. So all those things sort of stop you, even though you could go faster if you knew that you're far away from the limits. So the basic idea of my project is to try and address above concerns with modern and cheap telemetry technology built around Arduino modules. It all starts with lap timing. We know it's very useful to have a lap timer, but we build a system that keeps track of our lap times, and on top of that, more importantly, store for each lap time a large set of telemetric data collected from multiple sensors. Such telemetry data is exported to the cloud and is further processed to understand where did the lap improvement come from and what are further areas where gains can be made. So this is how we derive useful hints, where to make an improvement. What is interesting in this is that we are having telemetry data and its relation to lap time. We can even go further by introducing analytics and making it real time. So what do I mean by this? For example, by using our previous best lap telemetry data that we've captured, we can build intelligent dashboard recommending us what areas we should focus on to get better or to signal dangerous maneuvers and do it in real time. It's almost like having a personal trainer constantly pushing you to make progress and, more importantly, pushing you in the direction that won't harm you. As we all know that motorcycle riding is always a risky hobby. If we could push that analysis into real time, such dashboard could even let us know about the optimal braking markers, when to roll on throttle, and how fast to go in each part of the track. Okay, so what do we need to achieve this? Let's get technical and walk through all the components I plan to use along with the dashboard design. So let's start from the basic elements, which are the sensors. The heart of the whole solution is Arduino board because it consumes minimal amount of power. I was considering Raspberry Pi. It's slightly bigger, more power needed, and I think Arduino will do just fine, but I get the impression right now that I will need Arduino Mega, which is this part, this chipset. It's very cheap, around 10 bucks, and this is our heart for processing and collecting data. To Arduino board, we will be connecting multiple different sensors. So let's start from the gyroscope and accelerometer. This is that little MEMS-based chipset. It gives us the readouts. I'm not sure if you will see anything on that, but when I rotate it on X and Y axis, it gives me the angles. So the intention is to use it to measure the tilt of the bike, how far do I lean during the corners, as well as how the geometry changes when I brake, as well as at throttle, roll on throttle. I'm not sure if this is gonna work because we know that there are different forces acting on the bike when it's in the turn and when it's leaned over, so I just have to test that MEMS-based sensor. Of course, it provides accelerometer readouts, so I will know how big are the forces during braking and acceleration, which is very useful during racing as well. Another little sensor attached to that board is time of flight laser sensor. This tiny bit measures the distance up to 2 meters, and I will use one for the front suspension and the second for the rear suspension. So when I'm braking, I want to know how far the front dives, and when I'm rolling on the throttle, I want to know how far the rear compresses. So that these readouts are also very, very useful because each time you make that input brake throttle, you affect the geometry of the bike. Either it turns better or it gets a better traction out of the corner. Okay, let's move on. Here's the Arduino Mega, and to it we've got connected another TOF sensor, as well as a much bigger TOF sensor that works up to 40 meters. So it's just for fun, but I bought this because I want to attach it to the tail of the bike, so it could scan the back, what's happening behind my bike. I want to measure the distance from the riders behind me, get that data, and possibly use it to inform me whether someone's closing up on me and trying to overtake me. I'm not sure if it's gonna be useful in racing conditions, but knowing that you've got someone on your tail that tries to overtake you is very important, because then you can change your lines, you can block that user, so that might be an interesting feature. And I plan to use LCD diodes to display information. So whenever someone's getting closer, they would start blinking at shorter intervals. So that might be a cool thing to have, but we'll see whether it's useful or more destructive. Not destructive, but providing distraction during the riding. Okay, so the next and the most important part is GPS. You can see it's blinking, and these are the intervals at which it's getting measures. I'm using uBlox Neo 6. Remember, you need to reconfigure it to change the baud rate, so how fast the serial is getting the data to Arduino, as well as the frequency of refreshes, because by default it reads out at 1 second intervals, and that's not enough to get the speed and lap time measurements. Alright, so these are those basic sensors. What we also need is, because we're collecting all the data, we need to store it somewhere, and I'm going to use SD card module. We'll attach it to Arduino so that we could store all the telemetry data on the SD card. Remember, it's 10 data points across all those sensors collected every second. And once we've got that data on SD card, we would want to push it out to the cloud to do further post-mortem analysis. And I'm intending to use Bluetooth module because it will let me connect to Arduino through my phone and use my phone as a proxy to send the file to the cloud. Of course, I could use a Wi-Fi module and then proxy it through a router software on my phone as well. So we'll see which one is better. First, I'll see if I can use a simple Bluetooth connection because it consumes less power. So that's it when it comes to the technical measurement and collection of data. Oh, by the way, I would forget about very important sensor. This one is an infrared contactless sensor for measuring the temperature. So what I'm going to do with that one is I will connect it to set it up for front and rear tire. There will be 3 sensors for each tire. So at the center, left and right sides of the tire, to get the constant readout of the temperature of the tire. If you're racing, you know that the tire temperature is super critical. I want to understand how the temperature changes as a result of my riding, as a result of the ambient track temperature, because this gives you confidence. If you've got warm tires, you know that you can push harder. If you don't have it, or that there is a significant drop in temperature because you were riding too slow, you've been blocked by other riders, you know that you can't risk too much. Another sensor that's useful and that will be added is the one where I will measure the pressure of my tires. So warm tires or warming tires causes the pressure within tires to rise as a result of riding or as a result of tire warmers. And you want to make sure that you've got your pressure kept within acceptable bounds. Too low pressure might affect your turning into the bends. Too high pressure may cause sliding of your tires. So each manufacturer has preferred bounds within which you should keep your tire pressures, and it's also affected by the tire temperature, which is a dynamic aspect of your riding and the outside temperatures and so on. So this is also something that I will be measuring. I plan to use these things here. It's a standalone setup. It's called CareUD, and these are radio frequency 433 sensors that you just attach to your tires tubes, and they measure it. I want to intercept it, get it stored through Arduino, and then processed as well as part of my data collection pipeline. So we've got all those sensors, and the final bit we want to do is build a dashboard. So how are we going to build something similar to this MotoGP dashboard? So this part would be our Arduino. The casing for Arduino will be built, by the way, using a FreeCAD designs, and then I will just 3D print it. Same for some of those sensors or modules. I will just print and casings to make sure they're not going to break down. There's a lot of vibration on the motorcycle, so we'll see how it works with those 3D printouts. But for the dashboard, you see you've got the display and you've got those diodes, and we want to reflect that in our design as well. We also have buttons. You can buy those on AliExpress very cheaply. So I've ordered a set, and we'll see how it works. You just attach it to your handlebar, and it makes it easier to manipulate and switch, for example, displays rather than pressing on the dashboards. I know you've got on your motorcycles those standard buttons, but they are cumbersome, especially when you're racing on a track. You don't have time to just press on something on the dashboard. You don't have time pretty much to look at the dashboard. That's why you've got those LCD diodes that provides you a much quicker feedback without even looking at those tiny details on the dashboard. But coming back to dashboard, my plan is to use Nextgen. Nextgen is quite a nice approach to building those LCD based dashboards, because it's got its WYSIWYG editor. Let me just show you how it looks like. So you can design a dashboard just using the UI. Oh, sorry. Let me just. Oh, I think it just died on me. Okay. It's a Windows virtual machine, but basically you've got the whole interface through which you can design your dashboard and then export to the LCD. It's got its main board at the back, so it doesn't overload the Arduino, and it looks pretty cool. It's interactive, so you can click on its parts and you can design multiple different visualizations, dashboards in one go. Use these buttons to switch between them and display the most important data. So it's all before me. I think I will just focus on speed, lean angle, lap times, and the temperatures, as well as the suspension operation. Somehow I will have to embed it within those dashboards and possibly use those diodes to signal the most important information during the track riding. Again, this is just a bare unit. You need to have an encasing, so all those plastic parts, and to do this we will use Cura and 3D printing. There are available designs for those dashboards on SimHub, but I get the impression that probably it's not going to be that easy just to print it out, because these are not for 7-inch displays, so possibly will have to design them myself in FreeCAD and then print them out, but that's okay. I would still have to go through that process to build the encasing for my sensors. So that's pretty much it when it comes to the whole idea and strategy to build intelligent dashboard and use that telemetry data. As I said at the beginning, it would be really cool not to send that data to the cloud. Of course, we can send it for history information and see how we were improving at each time, how the braking markers were pushed further, closer to the curves, to the bends, to the turns on the track, how harder we started to brake, how harder we started to, or quicker roll on the throttle when exiting the turns. That's really cool, but you just look at on the past data. And what I would try to do is also do the key analytics on the edge on Arduino, so that this dashboard could tell me directly after my lap, what should I do, what should I improve, what I should work on, what should give me the better technique and faster lap times. As a reference, the algorithm will use the best lap and will tell me how far was I off the best lap and in what area. Was it the braking? I wasn't braking too hard. Was I braking too early? Was I not rolling on the throttle too early? And so on. So having that real-time input and recommendations would make this dashboard truly intelligent and useful. Just like, as I said at the beginning, as a personal trainer, to make my improvements better, quicker, and safer. So that's it. These are the ideas I have. As you can see, I'm working on those things. So far, it's looking good. I can pull all the data. It's working. It required a little bit of tinkering and setting up those modules and sensors, but they're working. That's the most important part. And in the next episodes, I'll try to document the further progress. The key one would be to install it on the bike and see how it works, whether it's reliable and so on, accurate. So I'm hoping to find it out within the next few months. By then, I'll keep you informed how it goes. And of course, if you've got feedback, you're very welcome to share it in your comments. So that's pretty much it. Thank you guys for listening. Bye.